Okay, so this is exercise set 11.16. You'll notice that the top part of the sentence file for each of the exercises is in black. That's the part that we're going to complete. And then in green, we have the first part of the sentence reiterated, and then we're given an explanation, if you will, or a template, probably more accurately, although the template is also an explanation that tells us what to do next. So what we're looking at is this. We are being asked to complete the translation using the provided step-by-step method. Some of us really like this because it helps us to see the parts of the sentence in such a way that the whole then makes sense. Some of us don't particularly like it, and that's often because the form of the sentence is such that the quantifiers are not together at the front. In other words, they're not in prenex form. One of them is nested. So let's take a look at the first sentence. Every cube is to the left of every tetrahedron. So we've got two quantified sentences in the sense that if we break the sentence down, we're talking about every cube and every tetrahedron, and then they bear a relation to each other. So every cube bears a relation to every tetrahedron. That relation is the left of relation. What is nice about the step-by-step method, though, is that we talk about first every tetrahedron in relation to something else, and that something else happens to be every cube. Or if we start the sentence at the beginning, we see every cube has some sort of relation, right? And it happens to be with every tet. Okay, so that said, let's take a look at the sentence file again. Okay, so every cube, and then we're going to fill the rest in, is to the left of every tet. So let's start with how many tets we're talking about. Every, oops, sorry about that. Every thing, if that thing is a tet, then all the cubes, so x, are to the left of them. So notice what we've got. For every x, if x is a cube, then for every tet, x is to the left of it. Oops, sorry, I had a z instead of a y. Right, so for everything, if that thing is a cube, then for everything, if that thing is a tet, the x's are to the left of them, or the cubes are to the left of the tets. Now, more economically, we'd say every cube is to the left of every tet. All right, let's continue. We're told that all the small cubes are in back of at least one large cube. So remember, the article A here does not mean the universal. In this context, it's a single large cube, or more generally, it's at least one large cube. Now, the question that we could ask ourselves is, do we need to specify that we're talking about one and only one, or do we just say at least one? Well, right now it looks like we're safe to say that the goal of the translation is simply to say that we're talking about at least one large cube, or there is a large cube. So let's talk about the large cube. There is something. The thing is a large cube and all of the small cubes are in back of it. So we've got the back of relation x, y. Now, question for us, is it the case that, and I know we have some parentheticals to take care of, but is it the case that what we need to do is replace the conjunction with a conditional, right? We're told that it is a universal claim, and the standard translation for a universal claim is the arrow, right? So is it the case that we should leave this arrow as our main connective so that everything on the right side of the arrow is the existential large cube, which is in back of which every small cube is. I know that's grammatically really awkward, but that's sort of the technical reading here. And it looks like we're safe with what we've got, but let's just hold on to that because we may need to come back to it later when we're checking our translations. Now let's take care of our parentheticals. We need to have the universal covering the whole, right? So the scope of the universal has to cover the whole sentence. So that set of parentheses that I just highlighted takes care of that. But we also need for our existential to cover the relevant elements for that scope. So I added another closed parenthesis. All right, number 3. There is some cube, or there is at least one cube. It is in front of every tet. So once again, we need to talk about the every tet sentence. So for all things, if that thing is a tet, then we've got the some cube in front of it. So now we've got the front of relation, the cube thing, and the every tet variable. Number 4, there is a large cube and it is in front of a small cube. So there is at least one small cube and now we're going to talk about the existential large cube. In other words, there is something, it is a large cube. So we're going to use the front of relation again. And we're going to say that the large is in front of the small. Now, we're going to want to specify that the x's and y's do not refer to the same cube. Now you might say, well, do you really need to, or you might ask, do you really need to do that when the front of relation can't be a self-referential relationship, right? Front of includes within the concept a different location. But I'm going to go ahead and do it anyway. We can always play the game depending on what we're checking in terms of the worlds we open to see if it's really essential. Sorry, I forgot my conjunction, right? But I think I've mentioned to you before that I have a preference for specifying that the x's and y's are not the same object where we are talking about two different sets of the same object. Again, I recognize that the front of relation should make that two set difference clear, but it shouldn't alter the meaning of the sentence if we assert a non-identity. All right, number 5, we're saying that nothing, right? So everything not, and then we need to articulate what we have in the green. So we're saying X is larger than everything. All right, so we've got a universal Y. We've got a larger relation, and we're saying X larger than everything. Now we can read back the whole. For every X, it's not the case that for every Y, X is larger than it. That's pretty unwieldy, I know. Here's another way to articulate it. Nothing is larger than everything. So here, notice we're reading back from our larger relationship, right? So nothing is larger than everything. Number 6, we've got, I've highlighted the part that we need to replace, which is just a set of dashes, right? We need to replace it with X is in front of every tet. So we need an every tet, right? In front of which we have all the cubes. So we've got the front of relation again. Now let's check our parentheses. We've got the parentheses around, no we don't, now we do, around this universally quantified sentence, right? And then we have a pair of parentheses around the quantified sentence at the front, and then lastly the range that includes the all the large things. All right, let's read this back out to ordinary English. We're saying that all the cubes are in front of all the tets, right? And now we'll add the second part. All the cubes that are in front of all the tets are large. Okay, number 7. X is to the right of a large cube. X is to the right of a large cube. So we've got at least one thing. The thing is a large cube. Where'd I go? Here we go. Close parentheses, right? So we've got that part done. Now what about our parentheses? How are we doing there? Well, we've got our existentially quantified sentence covered. In other words, there's no free or unbound variable. And then we have our universal covering the x's. So there's no unbound variable there. All right, so let's read this back. We're saying that everything to the right of a large cube is small. Now, what am I missing? As I'm reading it back, I'm realizing, oh yeah, I've got to talk about the right of relation. Okay, so here's what we've got in terms of the existential. There is something, it is a cube, it is large, everything is to the right of it. Okay, again, not very economical, not very elegant in ordinary English, but that's the I'm just reading it as written in notation. Now we can come back to the complete sentence. Everything to the right of a large cube is small. All right, two more. I'm going to do what I did before I started recording, namely, I'm putting everything in both the sentence that we're meant to complete as well as the step-by-step process instructions on a single line. So the translation's on a single line, and now the green step-by-step is on a single line. Not quite sure why Montague's sentences opens up without that being the case. All right, so we're supposed to say that entity, so X, is in back of a cube and entity X is in front of a cube. So we've got something that is a cube and entity X back of it, and there is something, it is a cube and X is in front of it. Hold on just 1 second. Let me make sure. There we go. We get everything on one line. And then we're done with our translations, or translation. Let me make sure that our parentheses are in the right place. So we have the universal covering the entirety of the sentence. We have an existential covering the entirety of the second existential scope is covered. Oh, but we're missing a parenthesis here. And we also will need another parenthesis to separate out basically the antecedent from the consequent. All right, second to last exercise. There is nothing in back of X, right? So nothing in back of. So for every Y, it is not the case that nothing is in back of X. And we should be okay with our parentheses, right? So for every X and every Y, it's not the case that the Y's are back of X, right? So now we need to understand how to read this, including cube X. So we're saying that nothing in back of X is a cube. Nothing in back of X is a cube. The last sentence tells us that X is smaller than some tet. So there exists something, the thing is a tet, and X is smaller than it. And we want to make sure that we've got the scope of the whole. Okay, so here's the sentence now read back. All the dodecs, or every dodec, is smaller than some tet. All right, our next project is to open up the various worlds and test our sentences against them. So let's do that. Remember, as always, save your work as instructed, save it in a place that's easy to find, and make sure you save it correctly so that that's part of the save it as instructed, so that when you submit the file, Grade Grinder doesn't wonder what you're giving it. All right, so we're going to open Peirce's world, Leibniz's world, and Ron's world. And where I'm going to make sure that what we're asked to do in once we open each world is visible to us so that we can go back and forth, right, instead between the world and the sentences in question. All right, so we are supposed to notice that all the sentences in the ordinary English are true in this world. So let's read through them together. We can adjust the world in terms of the viewpoint, the visual perspective, as needed. So the first sentence says, every cube is to the left of every tetrahedron. Yep, all the cubes are to the left of all the tetrahedrons, or tetrahedra. Every small cube is in back of at least one large cube. Every small cube is in back of at least one large cube. And that's true. Take a look at the large cube in the front, and there are rather two cubes in back of it. Here's another cube and another cube, each one of which is small. So we have a true sentence there. A large cube is in front of a small cube. So we have at least one large cube. Oh, sorry, I think I skipped over number 3. Some cube is in front of every tetrahedron. So there is at least one cube that is in front of all the large tets, or sorry, just the tets, and that's true. Then a large cube is in front of a small cube. Yep, there is a large cube and it's in front of a small cube. Nothing is larger than everything. I find this sentence to be a little bit conceptually peculiar. I mention this because we've talked about the ways that some sentences resonate or not with us. This is one of those or nots for me. So nothing is larger than everything. There is not one thing that is larger than everything, I would say, else, right? And that's true because we've got at least two large things. I'm highlighting each of the large cubes. So notice what I did there is I adjusted the way that I articulated the sentence to make it more sort of conceptually palatable without adjusting the meaning of the original. Number 6, every cube in front of every tet is large. Every cube that is in front of every tet is large. So even though this cube is large, it is in back of the tets, and the sentence has, the sentence says only that all the cubes in front of all the tets are large. So these tets, although they're not large, are not in front of all the cubes. In fact, they're on the same row, or sorry, I meant to say tet. All of these cubes are on the same row as this tet, but the one cube that is large is in front of every tet. Number 7, everything to the right of a large cube is small. So we've got our two large cubes, and everything to the right of these large cubes is small. Nothing in back of a cube and in front of a cube is large. Another way to articulate this sentence is as follows. If it is in back of a cube and in front of a cube, then it is not large. Now, here's something that's tricky. We've got the and, right? It can't be the case that there would be anything that is both back of and front of, right? So it would seem that the reasonable translation here is if it is either in back of a cube or in front of a cube, then it's not large, right? So let's hold on to that. We'll come back to that in a little bit. But now, is it the case that there is anything large that is in front of a cube or in back of a cube? Well, this cube is front of this cube, and this cube is large. This cube is back of this cube, and it's large. So how is the sentence true? It would seem that if the antecedent is false, then the sentence is going to come out true. Now I say seem that because there's one way that the antecedent can come out false, and that's if we translate literally back of and front of. And we know that it's impossible for there to be anything that is both in back of and in front of at least one cube, right? So whether or not it's large is, in this sense, in this context, irrelevant. If the antecedent is false, then the sentence as a whole is false. All right, number 9. Anything with nothing in back of it is a cube. Anything with nothing in back of it is a cube. And I translate this, or reword this, I should say, as follows. If there is at least one thing with nothing in back of it, here we go. If there is anything with not even one thing in back of it, then it's a cube, and that is in fact the case. So everything that you could articulate, everything you could identify as having nothing behind it, nothing back of it, is in fact a cube. And then lastly, every dodeck is smaller than some tet. There is no dodeck, right? Once again, antecedent false, so the sentence as a whole is true. Okay, so now what we need to do is check that all of our translations are true. Let's assume that they are all true, right? Let's assume that the translations have come out true in Peirce's world. Remember, that does not guarantee that we've got an accurate translation. That is a translation that exactingly reflects what the original English language says. All right, so first we've got a couple of issues with what should be non-well-formed formulae. So here, yes, we've got a problem with a parenthesis. That is, I forgot to put the closed paren on, whether it's the closed paren for the universal as a whole, or we're talking about closed paren for the second quantified sentence. Number 3, same thing. And number 4, I believe, oh yeah, same thing here. And sorry, I'm going to make the world smaller so we can get everything on a single page. All right, let's check again. Missing, again, another closed parenthesis. All right, so everything comes out true in Peirce's world. If I said Peirce, sorry, it's an accident. I'm so used to saying Pierce College, but Peirce is Charles Sanders Peirce, one of the first of the American pragmatists. I say one of the first, meaning that American pragmatism is a North American, more specifically United States, homegrown philosophy. There are others. There included in the group John Dewey, as well as William James, brother of the novelist Henry James. But Peirce is also a mathematician and logician. All right, so anyway, we've got Peirce's world, we've got all the sentences true there. Now let's open up Leibniz's world. English sentences 5, 6, 8, and 10 should be true while the rest are false. So we'll check that. So 5, 6, 8, and 10 are true, yay, while the rest are false. By the way, doing these cross-checkings, that is doing cross-checking in multiple worlds, is what should provide us with confidence that our translations are not just true or false in a world, but that they are actually accurate. That is, that they translate the sentence in the way the sentence it means. All right, and then Ron's world, 2, 3, 5, and 8 are true, and the rest should be false. So Ron's world, 2, 3, 5, 2, 3, 5, and 8 are true. The rest should be false. Let me make sure. Oh, 4 as well. Good. Okay, so 2, 3, 4, 5, and 8 are true, while the rest are false. Now, on your own, you can go ahead and trot through these worlds, comparing them with the various translations. Doing so should give you a pretty good sense of why a translation is true, why a translation is false.